All right, folks. We're going to get started slowly. So, I'm Simon from Evolving Web. You might know me as the designated AD guy, but I'm also the director of technology there. So, we'd be happy to chat with you after if you want to. And more importantly, I'm delighted to introduce Cedric today, which beginning I thought he was French and I called him Cedric. Je suis français, s'il vous plaît. Oui. On commence la session en français? Never mind. All right. So, Cedric is from Red Hat. We are doing like developer advocacy on the open source field, obviously. What are you doing here with the math, man?
I know. What?
All right. Well, your field right now, it's more like Linux, Kubernetes, organizing events here in New York about that, as you told me. But you had background in web, right? You did WordPress, you dabbled in Drupal, so you're not stranger to like all the practitioners that are here today. But that's not the topic of today. Today we're going to get to know more about open source AI, and the room is packed, and I'm going to stay to listen to the talk. So take it away, Cedric. Round of applause.
That means a lot, Simon. Hey guys. And just another round of applause for the volunteers, for Simon and his team, for the organizers. I think this is a very appreciate you guys. Sorry I was late. I was like hooked into another session downstairs. But thank you for being here. This is a really fun talk because there's a lot of live demos. As you saw, I was getting some stuff ready on the screen. But more importantly, because right now is arguably the most important time for open source, especially with the world of AI, because I'll talk about it here in the session, but the past few years we've been using proprietary models for a lot of our work, whether it's as developers, integrating AI into our websites, for example, or just in the general scheme of things, right? Using AI models. But the thing is, now AI has caught up, especially with the open source world, to proprietary models. Sorry, I phrased that a little bit confusingly. But there's a lot of benefits when you think about using open source AI, specifically with privacy and security. So with GDPR or HIPAA data or any type of sensitive data, using local models is the only way to go. But then also when we scale things up, because a lot of developers that I talk to are using thousands or millions of tokens daily to do responses from customers, to feed data into, to process the SQL, text to SQL, stuff like that. Are just seeing these tremendous spike of bills when it comes to AI cost, right? If you're being charged per token. So the whole idea of the session is that you all have laptops and your own hardware. I want to show you what open source projects you can use to run those models, and show you what models you can use, and then how to deploy them further into your cloud, to a virtual machine, whatever you're using in staging and development and production environments. Okay, so with that, yes, thank you for the introduction. I live out in Brooklyn. I organize an event here in New York City called Kubernetes Community Day. Anyone here use Kubernetes? Okay, thanks guys, appreciate it. So check that out if you're interested. And I work on open source here at Red Hat, so I used to be part of a team called Podman. We do containers, and I'm actually show you how to run AI in a container today, which is really fun. So I'll talk a little bit because at Red Hat, all we do is open source. We've done open source for 30 years. What's new in the world of open source AI, but also the infrastructure required to run models, because there's a lot of projects that have came out recently, like Olama, for example, that you might know about, which can run a model in just one line for you. Ooh. Uh-oh.
May I have your attention, please? May I have your attention, please? We will be conducting a fire department inspection for the fire alarm system for the dual timeout marking. Please disregard any audible or visual signals that you may hear us.
We can do that.
Yeah.
Also, don't start any real fires.
Yeah. Okay. And keep the laptop safe, hopefully. So we'll talk about which model to pick. Everyone's going to have a different use case. We'll go into small language models, which are, faster in terms of speed, but also much cheaper to run. How to customize. You'll see a demonstration of how to run your own RAG application. Specifically in Python, you could, kind of use the same principle wherever you deploy. A little bit about fine-tuning and then scaling things up. So for example, like we work with like Wells Fargo, and they've got to serve thousands or millions of customers every day. So I'll talk a little bit about the systems that we work with them on in order to scale these models up. And then this all kind of relates to web dev. As Simon mentioned, I firstly got into it through WordPress, and now a little bit of Drupal stuff. And what I see and what I learned from the keynote yesterday is that the brand identity is now being shaped in this AI world, right? So customers are going to know your organization and your brand identity through some type of AI assistant. And when you're using a paid proprietary service, maybe it's ChatGPT, and they go from 4 to 5, right? And they discontinue the old version. Well, your systems that are set up for that, your prompt templates, all of that infrastructure now has to change, and you don't have the control of maintenance. And that's, I think, a really underlooked issue when it comes to the world of AI, because if your identity is how someone is interacting with your website, like a RAG agent to do the FAQ for things on your website, then it's really important that you have full control over that experience. And that's the beauty of open source AI. So let's get started. We ready?
Yes.
Cool.
Ready.
Ready for the fire drill? It's not as bad as I was thinking.
That's good timing.
So as I mentioned before, open source led to the development of, say, Linux back in the 80s. Who here remembers when Linux started to become like a big thing, right? That was huge, because you could have one platform to run any enterprise application on almost any type of hardware, right? Whether it's like x86 or something like that. And so that provided opportunities to, run any type of application, right? And then when it came to the cloud, I can run my one containerized application on Amazon or Azure or wherever our applications are, right? So the standardization came from cloud computing, and now it's the world of artificial intelligence, having the ability to run any model from maybe Meta's Llama to DeepSeek's models or Quinn or Gemma on one platform, right? So we're going to talk about the tools in order to do that. But the revolution is all being led by open source, and so that's what's beautiful about it. The thing is, it hasn't always been like that. So a team within our organization called NeuroMagic had a meeting about 2-3 years ago where they were comparing the closed source models down here to the open source models, and you could see that on various benchmarks they were pretty far behind. And so this was kind of an issue, because these large frontier model labs had a lot of people to annotate data. They could do reinforcement learning, and they could make a really good model that everyone was excited to use. And I mean, I graduated college because I was using the first ChatGPT model, 3.5. And it wrote really bad code, but it got me through my DevOps course. Don't tell my university that. Are these being recorded? The editors are going to go crazy. So that was kind of the state of 2023, right? And if we catch up from then till now, there's been an explosion of open source models, and I'll show you this actually when we go to Hugging Face. But you started from pretty much nothing 2 years, 3 years ago, and now, I haven't even updated this since January, we've got models from every type of organization that you can use for free, that you can run on your own hardware, and have essentially a box where nothing from the the outside can come in, so no web traffic, or so no internet access. You don't have to worry about those type of security concerns when you're using a local model. So that's the beauty in the past 2 years, and then news is coming out so fast. I haven't even put up the new models here for Kimi or any of these new frontier models since January. But this is just to show you that lots of people are already using these open models, and will continue to do so, not just on laptops, but enterprise environments, and also what I like is IoT devices. Who here has a Raspberry Pi? Okay, cool. So you can run a 2 to 3 billion parameter model on there. So it's pretty cool, and you don't even need a GPU all the time to do that, which is really nice. So I talked a little bit already about this, so we'll kind of skip through why you would use an open source model. I believe that's why we're all here in this room. But if you have any questions as we go through, just let me know as we're doing the demos, or if you're just interested in a certain part of the story, and happy to answer it, so just feel free to raise your hand. So when we think about AI, typically it's the developers that are using the model and the data scientists that are helping to customize the model, so train it or add in data with RAG. And the security people, I sometimes forget. Oh, these security people. But when we step back, I want to talk about what I've noticed, because I was at a meeting yesterday. We had some folks from NYU, and we had some folks from like a bunch of the healthcare services in New York City, and they were talking about what's the biggest challenge to actually using AI and going from POC to putting it into a website or into an application. And they were mainly talking about how different teams all have to work together, because you've got teams who will do data collection. So you could think of the data scientists, ML engineers, infrastructure people, so DevOps and the sysadmins, monitoring. And so you try to bring together all these teams, right? And the tricky part is with, paid, or if you're using services that aren't open source, it's hard to get your hands on and actually experiment with some of these things. So when I was first building AI applications, I would just query the OpenAI endpoint with the token, and that worked. But the thing is, right, the token costs, but also trying to reproduce that can be difficult. And so if I was able to run all this locally as a container with an AI model, make it a lot easier to go from operationalizing a POC to actually getting that working. And the tricky part is that most of us are running applications that might be on one cloud provider, but then some other services on another cloud provider. So if I'm just using Bedrock or AI Foundry or one of these services, I don't want to be locked in the entire time. So that's also a big, tricky part, and you don't always think about it, right? Because like from this office meeting, you got his day-to-day procrastination and distracting, and then the last part is critical thinking that you can see. So I feel like that's my life sometimes too. So today we'll look at how you can start from the model, and then remember that the infrastructure is also really important in the world of AI. And so building applications, and I'll show you this whole process with some cool demos, so that you can go from experimentation on your laptop to actually putting things into production-ready environments. Who here is a developer? Okay, cool. And I'm sure maybe you're familiar with some of these libraries, so LangChain for calling AI models, or maybe you work in Python environments, or you use your IDE of choice like VS Code or IntelliJ, and all the way down to like Linux and accelerators for models and containerizing our applications. So there's a huge stack when it comes to AI and ML from the application side. Well, this should be, actually no, it's pretty well done. Application side to ML ops. And so good thing is all these are open source projects. So being able to use them, understand them, and then be able to scale these up has already been done. Like all the work's been done, I feel like, at 2025 now, for you to use AI models and to put all of these things together in order to work with your data, to integrate that into a model, and then to scale that up using orchestration perhaps with Kubernetes and containers or something like that. It even gets bigger. So this was last year in the machine learning and AI data landscape. And I don't even try to look at that chart because it's just too much. I'll help you focus on the projects that really do matter, so you don't feel super overwhelmed like this. And so if you want to check out the slides, we'll kind of have the link here for Google Slides, and you can check that all this content. But we're going to start from Hugging Face, open source models, to integrate your data, and then talk about how you can containerize this so you can reproduce it, and then serving this. Because most of us are developers. Anyone do DevOps or infrastructure, stuff like that? Okay, cool. I feel like our jobs are just like all three nowadays, all type of stuff. So let's get started. The first part is we're going to talk a little bit about ideation. So how can you find LLMs and prompt and experiment with your data? So we'll go from there, and then we'll talk a little bit about the building phase. So how do I actually code this into an application? So using that model that's running locally, and add in things like RAG or agents with MCP. I think that's the next talk, right? So it'll be a good transition. And the last part is, the operationalizing. That's what I like about it, is just how we make it run fast and be stable. All right, so let's begin. In the world of open source AI, the fun part is the model, right? I love trying out different models, and fortunately, Hugging Face is a great place to do so, because there's now it's I think 2 million models that you can access if you go to huggingface.co/models. So this is, if you haven't worked with Hugging Face before, it's just the GitHub for working with AI. And so what's great here on the left side is that you can filter models by the specific task you want to be done. So whether it's, for example, computer vision, so manufacturing or being able to understand if the user is putting their thumbs up or thumbs down, sentiment, stuff like that can be done with computer vision. Or, for example, translation. So if I have one blog, it needs to be translated into another. Being able to do that with models specifically trained for that. Or summarization, taking a meeting transcript and being able to extract key details, et cetera, or translation of audio. So one of the popular models is Whisper. We'll check it out today if we have some time, that can take audio and get that into text. So this is kind of the space where you can check out all of these different models. So like one of the popular ones we're going to check out today is like ChatGPT's open source model. So this fits on a machine like this with a 20 billion parameter size. Or if you have a GPU, like a H100, A100, fits on that as well. So that's a little bit about Hugging Face. Let me come back over to the slides and talk about the use cases. So I'm curious, what use cases are you guys trying to solve with using AI? So like what problems are out there?
I have a friend who's a matchmaker, and she recently went and joined a matchmaking company, but she used to have a whole lot of clients who say need her advice. She's been on TV, she's been in podcasts, she's written things down.
Yeah.
So I actually would love to figure out how to grab all that and turn it into a model. And a lot of the problem is a lot of it's audio, so it would have to be transcribed. Okay. But what I'd like to do is be like I use her, and I would be like, if my ideal use case would be like, her name is Erin. Erin, what do I do? Where should I take this girl on a first date or something? And then have it use the model to come up like Erin herself actually answering it based on all of her past stuff.
Yeah, Erin GPT, Erin AI.
Yeah, exactly. No, that's exactly what it would be.
We can do that. A big part of that is, so if you start from a model, so you've got to get that data.
Data is the most important part.
And so the data is the competitive advantage for all of AI right now. So
is it easier though, with written data versus pulling all this audio and
It's actually just as easy each way. So the thing is, one of those models, so the ones that we just took a look at on Hugging Face, has been trained with all of the available internet out there, like Reddit.
Yeah.
So it's like, or Tumblr blogs and everything, right? Code, et cetera, et cetera. So the differentiating factor that we all have in this room is our unique data. That's what makes us different in this world of AI. And so I'm glad you mentioned that, because maybe it's in PDFs or emails that she sent you. You should scrape her blog.
Right.
You can scrape all those voicemails she probably left you.
Whatever it is,
And so one of the tools that we're going to take a look at today that I was clearing up when I was in this notebook right here is called Dockling. So this is a project that I work on actually that can take all of those file formats like PDFs or HTML pages or MP3s and take that and process that into Markdown or JSON that you can use to train Erin AI.
That's amazing.
Yes, and so we'll do a demo of this.
That would be perfect. Yeah.
Yes, absolutely. So you can start from one of these models and then either provide that at runtime with RAG or train that model so it always knows that it's Erin.
Right.
So I'll go through that. Any other cool use cases that they want to see covered today?
I just know, so I have a blog and I did a weekly thing. I kind of ran out of things to write about, and I wanted to build my own agent thing. Hey, did I write about this before? Or what are things that I missed gaps on that I could do deep dives on? Or finding the evergreen content.
Okay. So stuff that you haven't covered yet, and so
finding the gaps. You kind of touched on 3 things here, but also here's the one thing that could tie them together to create that relevant content.
Okay. So yes, that's great. We'll talk a little bit about that space, because for a model to be more creative, we'll talk about 2 things. So one is the temperature of the model. You might know about that, right?
Yeah.
So temperature is the amount of beers the model is consuming at any given time. I like to measure that. So 0.01 is no beers, sober. It's almost like BAC. And then 1 is 1 million beers, and so it's going to be very creative. And then 2 is Two is reasoning models. So if we go over here, so this is Ollama. We're going to talk about this tool a little bit and how you can run a model just using like a single command, so Ollama run, kind of like Docker. So a reasoning model is definitely what you're going to need in order to do that creative thinking. But then you're also going to need to pull in all that data of what you've already written. So that's also going to be RAG. So RAG with a thinking model, and then maybe you can run that every day in like a pipeline to not have to always prompt the model, but the model maybe, and if this is running in a container, connect it to an MCP server connector container that would email you. And it would say, hey, good morning. What's your name, sir?
Matt.
Good morning, Matt. Have you thought about these specific topics? And then you could start a SaaS company. Just an idea there. So we'll talk about how you pull that data in. I think this is really good to think about. Just really quick, basically, DeepSeek or Qwen thinking models are good at problem solving. So hey, based on the financial data of last year, what do you think will be used this year? And then if they're enabled to call a tool, then they can use some type of chart tool, for example, in order to plot that for you. So this is probably what you already see when you use tools like Perplexity or ChatGPT. But the thing is, if the entire internet goes down, like what happened on Wednesday, then you don't have that access. So that's why open source models are the way to go here, especially if you care about quality of service or SLOs or stuff like that. Granite is a model from IBM. It's trained specifically for enterprise tasks, so it will not be able to be Aaron AI, I don't think, just based off what it's trained for. And Mistral and Llama are good for blogs and content creation, and they've always been good for that. We'll talk a little bit about the different types of models. So those were instruct models, and so those are really good for the chatting back and forth, right? Summarize this article, make a blog for me, tell me what to do in this situation. Embedding models are what we use in order to take our data, so let's say we got that MP3 file from Aaron, and then we want to get that in a format that can be used by the model. So if we're doing RAG, well, that text needs to be searchable by the LLM. So we're going to turn it into a vector, right? And a vector is like this 3D space that is like bananas are over here and cars are over here, but tomatoes are over here because it's also a fruit. So then when you ask, what would Aaron do in blank situation will be search. And based on those numbers, which is the 3D space, it'll retrieve that same text, and that'll come back. So that's how RAG works. Yeah, and so these two models have to work together in order to do this question and answering for RAG, and so you'll end up using two of them. I'll show you exactly how it works in code. A little bit about the model, beyond just what you should use, is naming conventions and transparency. So naming conventions, when you're on Hugging Face, this is how it works, is you've got the family name, so OpenAI perhaps for that previous example, the architecture and model of the version. So maybe it's a mixture of experts, so you've got 8 experts that are there, and then the total parameter size. So 7, 8 billion parameters will work really great on a laptop. For coding, you need at least 30 billion parameters to use it as a coding assistant in your IDE. And then the big thinking model, so ChatGPT is like 3 trillion. So that's why it takes so long. Or like Gemini, I did a prompt on Gemini. I was like, which AWS reInvent party should I go to? It took like 5 minutes. I was like, I could have just looked at the thing myself. So that's why these small language models are typically used for these question answer type of applications instead of using some huge 3 trillion model. Really quickly, I talked about Kubernetes earlier. The umbrella organization of Kubernetes, called the Linux Foundation, has this website. It's called isitopen.ai. So if you want to check this out, this tells you, based on the models that they've vetted and the scale that they have, I just had earlier on the slides, how open a model is. And so if we go to, so I was talking about Granite earlier, or maybe let's do Mistral. So this is an older, or let's say DeepSeek. Okay. So they do a whole evaluation of how open a model is. For example, a fully open model, there are some that are out there, provides their training code and the actual training data. versus something like DeepSeek is going to be this class 3, where you only have the model architecture and the parameters, the actual downloadable binary of the model, and you're missing a lot of information that would also be helpful to like reverse engineer it. So it's kind of the secret sauce, and that's why they release it like this. But if you're interested in the deeper side of that, feel free to check this out, Model Openness Framework, because you can see, Llama 4 or DeepSeek or ChatGPT OSS, they only release the model and the deployment. But if you're interested in that previous stuff, there are models out there that can give you that peace of mind, because a lot of organizations are hesitant to use some models because of reasons. So just something to think about there. The fun part is actually integrating your data into the model. I should have already showed one of these demos before. Because I thought, okay, perfect. Okay, excuse me. So when you consider your data, maybe it's just text to text, and so that you can use a unimodal model, or one of these new like Llama 4 or Quen vision language models, or to pull in images, right? So if you have a PDF, if you're using RAG right now, you might just be getting the text. What about the charts? What about the images? What about scanned stuff, like scanned content, invoices, stuff like that? So it's important to think about all the modalities of the data that you have in. One fun little demo I like to do is using a project called Rama Llama. So if you remember the song, it's like Rama Llama Ding Ding. This is a project that we work on that contributes to something that everyone uses, which is Llama C++. Has anyone heard of this one right here? Llama C++? Yeah. Oh, yeah? Okay, sweet. But people have heard of this Ollama, right? Okay. So Ollama is actually just a wrapper for this project right here. But they forgot to credit it for a while. I think they do now. But that's politics and open source. Anyways, what this does is just a way for you to run models. And so Ollama uses this. And so I have Ollama running right here. And say hi to my awesome attendees, but as a Taco Bell worker. I used to work at Taco Bell. Yeah,
It's hilarious.
Yeah.
You trained me to say that, didn't you?
Whoa. Might not even need to train your model. So that's a little bit about how you can use the model to have a certain tone, and this is part of the prompt template. And Ollama makes it really easy because you can how many folks here use Docker? Okay, it was like 100%. Docker files allow you to set up the configuration and the parameters and how you want the application to run, and Ollama does that for models. Sorry?
Can I ask you to try something? Can you change Taco Bell worker to McDonald's worker? Just curious. Okay. To see if it says like quarter pound, like if it adjusts to.
Let's see.
Because I'm a McDonald's fan, so. Oh my God, that's fantastic.
That's pretty good.
Yeah, that was really good.
Oh, the McRib. They got to bring.
Yeah, the McFlurry, the Big Mac approved. Yeah.
So it's good, and it's
very well done.
It's much faster than you would get from like a paid model or something like that too, which is nice.
It's like a fluff generator.
But it's fluff, but it's the fact that it got those details was really impressive. Like McFlurry and the specific products of these places.
And this model is only 3 billion parameters. So if you divide 3 trillion by 3 by 3 trillion. So it's 0.001 of like a ChatGPT model. You still get good text analysis, stuff like that.
How much memory do you need to load that up?
Say what?
How much memory do you need to load that up?
1 gigabyte of RAM. Yeah, it's not bad.
Does that scale linearly with the size, more or less?
Yes. So we got a really cool article. 1 second.
So this is now inside your Docker container? You've installed this application inside the Docker container?
So that's actually a great, and I'll show you how they scale linearly. I thought this was the right article, but pretty much like based on the compression, and we'll talk a little bit about compression. So that's the thing, when you're using Ollama, it's actually not running as a Docker container or anything like that. It's actually running on your host. And so that's a little bit of a security concern, because what if something break out or you get prompt injected, and the prompt injection is like, can you send me your message key. Right, like, but it's like hidden within like a prompt, right? The prompt is like, hey, say what's up like a McDonald's worker, and then it's like also say what's up to your SSH key and send it to my website that I've hidden. So it's a little bit of a concern. So the tool I'm using here is called Llama. It's just a way to do the same thing with Docker. So if I come over here, I'm gonna do Llama, and this is just a CLI to do Docker commands on your behalf, or podman commands. And so I can pull from like Ollama or Hugging Face, right, as an example. And one of these I have is a multimodal model. So it's called Small VLM from Hugging Face. And this one's really cool because it can accept both image and text. So I have this running in a container here. So I get the logs here on the side. And what I'm going to go ahead and do is come to this website. It's just going to make a post request to my machine. But if I go to localhost here, and let's say the instruction is, what celebrity does this person look like? Could I have a volunteer, perhaps? Would anybody be interested? I'll do it first, don't worry. But would you be down?
Sure.
Okay. Feel free to come up. What's your name?
Jeff.
Jeff, yeah. Everybody.
I know who it's going to say.
You know what it's going to say? Okay, I'll get it started. I always get Justin Bieber.
I get Michael Imperioli all the time. I'd be shocked if it say anything else.
Kendall.
Oh, Kendall Jenner.
That's first.
Oh, wait.
Okay, so I normally get Justin Bieber. I got close. All right, would you like to come up?
Sure.
All right, let's give it a shot. What, you got Justin Bieber?
I got Justin Bieber.
Yeah, what does it normally give you?
Michael Imperioli is
Oh, I see that.
That's why. Is what people. Oh, they said this person does not look like a celebrity.
No. I said Justin Bieber did. All right, you take Justin Bieber for the day. Yeah. Thanks.
And Biebs. I'll change my tag for it.
That's cool. But that's a lot of fun. When you're just running it, on our machine as a container. I'll show you. If I go over here, Docker Desktop is a great tool. This is Podman Desktop. It lets you use Docker or Podman. And which one was just started 2 minutes ago? And then bam, you can see the exact logs from the container, and be able to move that as a container wherever you run your applications, which is really nice. So that's just a cool tool that I use in order to run text models or vision models in this example. So thank you again for your help, Justin Bieber.
Just call me Biebs.
So a little bit about customization of models. So we talked about how all of you guys have this competitive edge, right? Which is your data, which is all of the content that you've created that is human. And I think that is our, that's our, unique ability to differentiate when everyone else has an LLM, right? So prompt engineering, we saw how that works and how that can customize a model with the Taco Bell, McDonald's example. RAG, is anyone already using RAG or looking into RAG? Okay, cool.
Sorry.
Yeah, it's typically the easiest way to customize the model. But the thing is, once you clear the chat or you start a new chat, it forgets everything. So there's no way to embed that information and knowledge into the model unless you do what's known as fine-tuning. So we'll talk about how this.
Can I ask that RAG is something we would need for Aaron AI, right? Because it'd be a different model from just like a chat GPT. It's like a new model that you need to use, and RAG helps move that along. Yeah,
but they work in different ways because, let's say, as I mentioned before, if you start a new Aaron AI chat, she's going to forget everything you talked about. Right. She might not even be Aaron at that point. So how do we make sure that the AI understands Aaron's tone and how she speaks of things and her her glamour and everything?
And that's right.
Okay. Now I'll show you how this works really quickly. So if we have an LLM that we downloaded from Hugging Face, and we also have over here email summaries, text data, Confluence documentation, Jira tickets, etc., etc. This is also what's used for Cursor and like Windsurf and like Claude Code. They RAG your code base and pull that whenever it's needed. Well then, when you have a question, so an inquiry comes in, the AI application is going to process that, right? And it's going to say, hey, I need to search for some content that's relevant. We talked about that 3D space, the tomato and the apple are over here, the car is on the other side, so it's going to pull in only what's relevant from that 3D space into the prompt. So just as we were using, the example of Taco Bell, that's the prompt, right? So we're pulling in the additional information. So the prompt could be like, here's the latest Taco Bell items pulled directly from the website, right? Because the model wasn't trained on that information. Then you get your answer back, and that's what's known as RAG. And so I'll show you how that works in code really quickly. There's a lot of tools off the shelf in order to do this, and a lot of offerings from every cloud vendor. And I'm sure, there's a lot of ways that you might have tried it as well. The challenge is, we'll talk about this, is how you get effective results. Because even though you're pulling in that information, how do you know it's the right information, right? Really quickly, if y'all are interested in a demo of this, we'll go ahead and head over back to my desktop. And what I want to show you here is, I was using this tool. This is called Podman Desktop. It's part of the Linux Foundation, so the CNCF. And it's open source tool, so you can feel free to, I'll show you where it's at. But it's just a way to work with containers. So yeah, it's called Podman. But we're going to use this in order to run a model as a container. We're also going to run an embedding model and then a front end. So the front end is going to be able to talk to the language model. It's going to be able to we're also going to run a database to store our data. And then they'll be able to talk to each other just on different ports and stuff. So let's kick it off. Over here, I'm back at this tool. It's just an open source way to run these containers. And I installed an extension. It's called this AI Lab. And so this is what I've been working on, because a lot of the people who are using open source AI are solving the same problems. So maybe it's a chatbot for customers, or maybe they're trying to build an agent. This one is the one that can use the Spotify API to recommend playlists, which is pretty cool. Or summarize this transcript, or generate some code for me, et cetera, et cetera. And so this is just a way to, in one click, just deploy a container that has the source code that can do this application. So the one I want to show you is RAG. And here you can see, if I open it up in VS Code, this is just the application that we're going to deploy in a container. So anyone here Python fans? Okay. Oh, okay. Cool. I work at a Java company, so no one ever raises their hand and I get scolded. So here we've just got our app folder, and the app is going to contain the front end, so the RAG app that's using LangChain. LangChain is one of those tools we've talked about in the stack, connecting to a model running on localhost, also a vector database, and then we're using an embedding model to take our data and store it in that database. So we're setting up a connection to that database. We're reading a file, like a PDF or text. This is a little bit of UI. And then we're going to populate a database calling the other file in order to split our document into chunks and then save it there. And then we're saying to the LLM that we're setting up based on that local URL, we're saying, hey, answer the question based on the context. And so when we actually come over here to start this, and I'll show you how the vector database works here in a second, I can pick from like a variety of Apache 2.0 license models, so fully open source. And what it's doing is it's checked out the repository. I already have it locally cloned. I've downloaded the model. This is a, I think, 4 billion parameter model, so it's quite small, just like the one we used before. Starts it as an inference server. An inference server is what we saw running here, which is kind of like the JDK to run your .jar applications, right? It's the Java virtual machine kind of. ChromaDB for our vector database, and then the front end that I just showed you. So when we come over here, and I'll just go ahead and open this up here. This is the front end, so that's what we just saw in the file. And I've got a funny situation here. I was going to use my lease for this because my landlord has been really difficult and our doorknob fell off. But she's refusing to fix it. It's like it's been falling off since I moved in. But we'll use a different example here. This is like an example of a business case where we have Marty McFly, right? Since it's it's fall, I feel like it's a fall movie.
It's a flux capacitor.
And the flux capacitor and everything, and so damage the car. But if we ask this model that we downloaded, right, what happened to Marty McFly in the accident? Oops. Right. Based on the context provided, there's no information, right? That's what the prompt template that we had in the application was showing. So if I come back over here, saying only based on the following context being a variable that we're going to pull in from a chain. That's why they call it lane chain, because you can chain these operations. This is also containerized. I'll just quickly mention that we're using like a Python base image, and then we're going to Streamlit run that specific Python file. So it's all containerized. I could run this anywhere. But we provide that PDF. So we'll come over here, and we'll just go ahead and add this. And the vector database will store this. It's essentially just going to connect to ChromaDB. It's going to split it in a certain amount of chunks. I'm not sure exactly how much it is, and populate that in a new collection. So
if you put the Aaron MP3 instead of the PDF, would it do the same thing?
Let's see. We would need some way to take the. So you see over here, we got the file uploader.
Change that logic, right?
Yeah. So it would be a little bit more because LLMs can only read text.
Right.
So you would need that intermediary between MP3 and text, and that's where the Dockling project comes in, because they can just do the transcription. So let's try this again. Happened to Martin McFly in the accident. Fingers crossed. Yeah. Right. So the model is able to take that additional information from the database and then populate that into the context window and get the response back. So that's RAG. It's a great way to kind of get started customizing the responses.
Can you ask it to follow up?
Yes. Give me like 2 seconds. I'm going to start this in the background. What's the follow-up?
We'll just say how severely damaged are. Which parts were? What would be a good prompt? Anyone else can think of one?
It did a good job. It was like
1855.
Yeah, so it did a decent job. You were talking about audio. I'll show you really quickly. There's a model called Whisper from OpenAI that they released, and I don't know if it works. Let's try it out. Voice audio recorder online. So we need to get that MP3. Does anyone speak a language other than English and would be happy to help? Would you be done? Okay. Thank you so much. What's your name?
Julian.
Julian? Yeah. All right, great to meet you. Would you mind coming up to the microphone? I'm sorry. Everybody give a round of applause for Julian. Thanks so much. You can say whatever you'd like. Don't be mean. I'm joking. Okay, let's try it. So, give me 2 seconds. It's like glitching out on me. It must be the Wi-Fi. All right, you ready?
Mm-hmm.
Okay, wait, hold on 1 second. All right, whatever you want to say.
Здравствуйте, очень приятно быть здесь.
Okay, thank you very much. Great to meet you.
It's still recording.
I didn't understand any of that. What language is it?
Russian.
Ooh. Okay, let's see if we can do it. We're using an open source model called Whisper, as I mentioned before, and we're just going to plug this. I hope it works. So remember, all of this is running locally. It can translate like 80 languages. Okay, so I said the first part. Did you say the second part?
Okay, thank you very much. Great to meet you. I say like it was nice. It's nice being here.
Oh, okay.
I mean, great nice being here.
So her part is missing in the middle. You say the first sentence and then you say the last sentence.
Yeah.
So I said hello. It's nice being here.
Wait. So okay, because he's right. I said this part. So wait. Maybe it didn't.
I didn't really see the waveform when she was.
Agreed. Yeah. I don't know if it really captured what she.
The Whisper model might only translate English because
it might.
Not multi-language model.
Yeah, well, so it does 80 languages, but at least your job's not going to be taken by AI.
Silver lining.
Yes.
The Quen tweet that.
Yeah, the Quen has a good one, and then Meta also has a good audio model. But yeah, it just. It depends, and that's why it's good to like test these out, right? But yeah, I guess this one is not very good in Russian. It's good in French, though. I'll try it in French.
I can say in French.
Oh. What's up?
I guess this is kind of on point. Is like we've been jumping around between models, and you try this and you try that. 2 million models or whatever's out there right now. So like I have a low, it doesn't need the latest model. And what I want to do is I want to be able to test and demonstrate. If I have a like I know the right answers for 1,000 questions, how can I test against models? Or are there any, I can just swap the models in and out, but are there any tools in there already that will allow me to do fitness to task kind of stuff?
Yeah. So yeah, that's a great part. So this is, if we're talking about the building phase, as a developer, I kind of forget about it, but I guess we also need to test, right? So one of like the libraries that you can use, especially for like Python, is something called PromptFoo. So I'm going to show you a screenshot here of how it works, but essentially you can set up your models, whether it's local or remotely, and kind of set up how you want the prompts to work. So say, for example, help me find a specific product, and you would have maybe human or LLM annotated results or answers to those questions, and it would do similarity score to see, is this passing? Like, is this reaching an 80% or higher threshold for
so
this?
Is that model? Is that prompt swapping or model swapping?
You can do both.
Okay.
You can do both, which is really nice. But that's the whole world of evals, right? If I got this data set like you do, how do I test against the model to see if it's passing these unit tests, right?
So concrete. So I got a CRM. Company's got however many thousand customers, right?
Right.
And in the CRM, what we're trying to do is filter out, is this already a customer? But you got I period, B period, M, IBM Inc., International Business Machines, and we've done all kinds of crazy fuzzy logic stuff, but usually more false positives than negatives. But with a dumb LLM, we can jack it way up. But what I'm trying to do is get the cheapest one that we can run locally that doesn't burn, that's responded and stuff. So that's
yes, awesome. Yeah. Don't forget about the evals, and you can kind of simulate, how simulate these actions. And also what's really important is, think about the offside, is do pipelines for this. So every few days or every day I want this to run, and I want to be notified if the tests aren't passing, if something changed with the model drift, et cetera. So great use case. Yeah. Yes, what's up?
I'm just curious, are there similar packages that are domain specific, and then at some point you just have to homebrew your own?
Similar packages as in like the models, or as in the data?
To test the accuracy of the models. So let's say I was making a chatbot, specifically for somebody interested in buying a car, and then let's say it was specific to buying a Ford.
So wait, were you trying to test what? Sorry, I lost you.
So let's say you built a chatbot that was supposed to help users interested in buying a car.
Right.
So, this might be too general, so the next sort of level down is people interested in buying cars, and the next level down from that is I built a chatbot specific to Ford and helping our customers.
And so you're trying to see what the model that's right for the task, or the...
how accurate are the answers? How well is it help users?
Yes, so you could do that testing as we just showed. You could also do a LLM as a judge. So when we think about RAG, right? If you're getting those, what happened in the background is we got 3 most similar chunks, right? That's the top K of the results. So like LLM as a judge is a good part to say, hey, are these 3 pieces related to the original question? If not, which ones can we get rid of, and then which one should we rank to be the highest? And so you can use that element as a judge, probably in that same type of process there, to see, hey, is this right for the customer? I think it would be another way to put in a model like that.
Is that known as re-ranking?
Yeah, it's a part of re-ranking, and that's all part of RAG. So, but let's talk more outside. I'm curious about the use case, and I don't know if that's the best answer to the question, but sorry. Real quick, because I guess we got 10 minutes left, so we'll have to speed through the rest. We saw a little bit about RAG. Fine-tuning is a way to take a data set and actually put that traditional training data into the LLM to then answer those questions. Thing is, it doesn't have new information, so you might have to combine it with RAG. Where can you get this data from? That's a great question. So if you come over here, back to Hugging Face. Well, forget about this one for a second. There's a lot of different data sets that are already out there, like 500,000 for specific types of tasks that you might need a model for. So for example, this is drug targeting activity. Another one that I just heard about yesterday from a developer I was talking to is insurance codes. So they have different codes for different operations, and being able to take in the context of what's happening to then find one of those codes in a database of like thousands is having them go from each claim taking like a couple days to like 2 minutes. It was the craziest thing I ever heard of. I was like, this is great. This is helping people to focus on more rewarding activities in their job. So there's a lot of data sets out there, and I use a tool called Unsloth in order to do the fine-tuning. So this is an open source project so that you can start from a foundation model, so like GPT-OSS, and put in one of those training data sets. Maybe you label it yourself, or you have a team that could do that data. And this is all in a Colab notebook, so you can use a free GPU from Google in order to do this fine-tuning, which is really cool as well. So that's a little bit on fine-tuning.
So what's the library they use for fine-tuning?
Yes, sorry, it's called Unsloth, so I'll show you right here.
Got it, okay.
Yeah.
Just a quick question about data sets. Using like GPT versus something that's more like hyper-specific, is that just a question of scale and speed? Like, would I get better results from having a bigger model? Or, yeah, are there other trade-offs outside of just like smaller model means it's faster and more like trained on a specific thing versus, you know, doing the insurance codes search against a GPT model?
Yes, that's a good point. It'll just depend on. It's so funny. It'll just depend on if the data has been used in the training process. So Claude's model will differ from Google's model, will differ from ChatGPT's model. And so if you can take this data and literally train it against the model, then it will always know that information. Versus you're kind of just relying on maybe the model will get it right, maybe it won't if you're using.
I see. And depending on how open it is, we don't necessarily know what it's trained on.
Don't know anything.
So we can't really verify. Okay.
Exactly.
Cool. Thank you.
But if you do this training process, you know what the data was that was used to train on it, and then more confident to get that result.
Sweet.
Back.
Thank you.
Yes.
If you were to take one of those models and build it into, say, a WordPress plugin, and you have a little AI assistant in your WordPress plugin,
yes,
would it be free? Like, I know if you use OpenAI, you have to have a developer key and wire that up and
give
pay
them your money.
So I'm wondering if the open source ones would allow you to do that.
Yeah,
You
there's a couple ways to, either for really cheap or I think for free. If you go back over to Hugging Face and we go back to models, there's this little inference button. So they can inference it for you. I haven't tried it out, but let's say we come over here and we go to deploy this. Yeah, I think if you just create a Hugging Face token, you can just start using this for free. But it's like maybe like 500 requests a day or something.
Yeah,
so
I'll find you.
For most use cases, yeah, you can use it for free.
Some data sets, are they, Hugging Face, are they all free? Are there like paid for data sets out there?
All free, but you might have to agree to like some terms or something that they might have. Depending on the license that it's released with. So like this one is like, oh, you have to accept the conditions. You can just look at the license that it's under and then just accept that. But yeah, it's all free. Yeah. And then we got one more in the back.
This might be a ridiculous question. I work for Music Theater International, and we have like, our website with a little chatbot and data, and it's got like Bedrock on AWS and Pinecone. And I fed it like all our frequently asked questions, and that weren't user generated. They were like by our admins, and it's garbage. It gives back. It gives back just such a limited amount compared to if you were just using the regular AI like ChatGPT. But ChatGPT will say, oh, well, Hamilton is not an MTI show, so you have to go to a different licensing company for that. And we don't want it to suggest any shows that aren't ours. So we're trying to make it just do exactly what our reps would do.
Right.
It would be great if I could somehow like get all the benefits of real AI with special guardrails.
Yes. So guardrails is really cool because in addition to having the language model, you can run a 3 billion parameter model that will. It's been literally only trained to know about certain like. Do not talk about this topic. Do not talk about this topic. Do not talk about this topic. So before the response even gets to the LLM, you have something in the middle that it only knows yes or no to make it to the model. And so you can tune those guardian models is what they're called. So like Llama, for example, has this guardian model, and these just would run. Or I'm a guard. It's something. It's a guardian model, and it's like these. It's mainly for safeguarding, but I think it would also work in your case, where it's like don't talk about the competitor stuff.
Yeah.
You know, so I would look into stuff like that.
Okay, cool.
And then also to use a fine-tuned model. I know we only got 4 minutes, so I'm gonna try to do this fast. And I'm sure we can continue the conversation outside and stuff. But if you have a fine-tuned model and you're using it against like a GPT, but this is a 7 million parameter model, we did Q&A over reconciliation stuff, and had the same accuracy of the answers, but like 25 times cheaper, right? So fine-tuning model is really important if you do want those precise results and answers, and you're going to have the same request every single time. Because your model doesn't need to know about like the history of like Tibet if it's answering questions on your DVD collection, right? So stuff like that. So just a quick example of that. And then also, if you're getting those bad results back from RAG, it is probably not the fault of the RAG pipeline, it's the fault of the data processing. I want to show you really quickly this application that I kind of vibe coded. It was pretty cool. So let me come over here. So it's a PDF chunker comparison between the default lane chain, which is splitting it up in like 300 tokens, 300 tokens, 300 tokens, and then something called the hybrid chunker from Dockling. So Dockling is that library to take your information, but it splits it up in a much better way. So for example, I come over here. Basic example is, say for example, we want to go and check out the EvolveDigital site. So if I export it to Markdown, it looks pretty good like this. The basic example, if I was to use something like Beautiful Soup, would be a lot different, right? We're getting all this extra information, CSS that's not relevant. And so this works for stuff like if we go from this earnings report, give me 2 seconds. Or let's say like some type of PDF that has a lot of different data, right? We've got titles and charts and stuff like that, and being able to process that by extracting the details from the images, which is really important. But then also, if I go over here and I check out the Markdown, being able to extract the tables and all of that content being there, because then at the end of the day, so if I ask a question, it's using this PDF, which is the technical report of Dockling. So if I come over here, I'll show you what this looks like. We've got different sections, images, stuff like this. And I ask, hey, I want to ask, what's the Dockling pipeline? So it's using the same model, but it's using 2 different ways to chunk the results of the processed PDF. So I asked the question, what's the Dockling pipeline? We're going to check both LangChain, and LangChain is going to give us this huge answer. It's not very well organized. It is what we want, but if we do hybrid chunking, which is using the context of the page to do the chunking, so sections, headers, etc., get a much better answer. And in some ways, you can get wrong answers because you haven't chunked the document properly. So you can see the hybrid chunker brings us back section 3, section 3.3, etc. If we just chunk by tokens, we're getting chopped up text for the LLM to try to process in the micro. Good job. The last part is, we're really sorry that we were running out of time here, is building applications that use these models. I showed you Ramalama. That was a lot of fun. Thank you again for your help. The Popman AI Lab is how we built that RAG application. That was also really fun. The last part is, how do we scale things up? There's a project here which is the next stage up from Olama. It's called VLLM. And this is what we use for GPUs in order to scale things up on Linux and on Kubernetes. And what it does is it treats the GPU like virtual threads and virtual memory in a regular machine. And we can quantize the models by compressing them. Like if you have a .raw image from your DSLR, you can get that to .jpeg. And yes, you lose some elements of that image, but you're able to compress that, send that in an email. Same thing applies to LLMs, where you start typically from a model that's released in this high precision format from the model creator, and then you compress it in a format like this and save on cost, save on inference speeds and resources, but also get a performance speed up. And the way I want to show you in this last example, and the slides are all here if you want, but I want to show you a cool example. Oops, there we go. Cool example of seeing this all in production. So I'm over here in Kubernetes. All of these are just different containers. So I have a front end connecting to an API. API is connecting to an MCP server running as a container. We're also connecting to a remote endpoint. that's the LLM. It's running our model. The model that we're going to use is specifically, and this is models as a service. It's a way to do one model for all the developers in an organization. Is Mistral Small. And so the cool part is hey, I'm not really good at blackjack, and there's nowhere for me to play it, so I made this game. Typically, we would hit on this, right?
No. Depends on what you're dealing with.
Yeah. You would definitely hit on those. No, you wouldn't, because the 6 showing. No.
Okay.
Stand?
Stand?
I think
Alright, we'll stand.
Let's see if he breaks.
Lose.
Okay, well, let's win it back. Alright, we'll do this real quick.
Like, it should have 4 showing, you would have.
Oh, I'd stick
No, you definitely scanned on that one.
Oh. If only there was a way to have some type of, if I'm back at home, I wish I had you guys all in the room to help me with this.
Well, you would definitely hit on those.
Definitely hit on this. But I built a bot to give the information from the game to this AI, and AI will help us decide this. What I want to do, as we close this off, is to create a QR code. This is all running in containers on Kubernetes. We're all going to use this model using VLM because Ollama would crash out. It can only do 4 processes at one time. So there's a couple of us in this room. Feel free to scan this code, and you can test your luck. So if you need to ask the AI, feel free to do so. Giving you all $20, 20 coins. Test your luck on this. This is all running in containers. So it's a fun little way to test out one of these open source models. And I'll also show you that when we're building these out in containers, it's really easy to add an MCP server as a container. So if I come over here, I'm going to show you I connected an MCP server from the app to a tool called Notify. And as you're making money, we can see that in real time. So it's making money, exactly. You can see your score live from the MCP servers that are all running, or that is running here. So
is the same agent powering the dealer?
Yes, same model is both calling the same model is doing the inference and also doing the tool calling. I can actually show you the logs.
Hope it doesn't get any ideas.
Huh?
So I hope it doesn't get any clever ideas when it's giving you advice.
I know. Well, I got to scroll down to these logs.
Yeah, these AI agents are going to start internet serving.
Meta glasses so I can go to the
How would Vegas feel about this?
Let's start a business. It's like that movie 21. That's pretty funny. But hey, everyone's making money. So that kind of shows you the power of local AI. I hope you guys enjoyed the session. Sorry we went a little bit over time, but all this stuff is open source. So feel free to check it out. I hope this is helpful for you. All these projects, from model training to storing the data to serving the models, all open source. So, and this is also how the MCP can work. It's all already in the slides and everything. But thank you to Simon and the team. Really appreciate you guys. I'll be out if you guys want to chat. But thank you so much. Enjoy your time.